Welcome to the Stormsurf video surf forecast for the week starting Sunday, November 15th. First, we take a look at significant wave heights for the North Pacific Ocean. We see an area, this is actually associated with high pressure. You can see all the dead air here, and low pressure inland creating a gradient, creating seas, mainly very choppy, pushing into California and the Pacific Northwest. We also have another area of low pressure generating was about 25-foot seas aimed south, not quite at Hawaii yet, but maybe some in that direction in the days ahead. And then something up in the Bering Sea, and yet another something trying to get going off Japan. But overall, the pattern is not stellar at this moment. So let's take a look at jet stream level winds. These winds up about 30,000 feet help support the formation of storms, and when those storms do form, help direct their track. Currently, we do not have a very good jet stream problem. That's the root of what's been going on the past week or so, and expected to kind of continue for a while. All this is driven by the inactive phase of the MJO. The inactive phase of the Madden-Julian oscillation typically takes the jet stream, steals energy from it, and then it sort of splits and meanders around and drifts to the north. Likewise, in the active phase, much more energy is imparted to the jet, and it tends to fall south, and that tends to be a lot more conducive to storm development. But for right now, we believe we are in the inactive phase of the MJO, no matter how odd that may seem, given that when you're in a strong El Nino, the MJO is supposed to disappear, but that's not completely true. We saw shades of it a couple months ago when it was in the active phase, did a lot to promote the development of westerly wind bursts, Kelvin waves, etc. So now we're sort of in an inactive state after just coming out of a very strong westerly wind burst that create Kelvin wave number 4. So it's not unexpected to have the atmosphere sort of take a breather for a little bit, try to regroup. And the thought is, as we get deeper into the fall and into early winter, things should really pick up again. Not so much for Kelvin wave generation, but just basically fueling the storm track as the El Nino base state takes over the atmosphere. So, with that said, right now we have a very diffuse jet stream pattern coming off of Asia. Sort of a little bit of a trough here, but you see winds are blowing over the top of it. It's mainly cut off almost, but just enough wind here to probably get some, and this is a trough, a dip to the south in the jet stream. That would help support low pressure, that is counterclockwise circulation in the upper atmosphere and down at the surface, and that would help maybe generate some fetch and swell. But then also notice, split here, big ridge, that is the jet pushing to the north, clockwise circulation supported there. That would mean high pressure. And then this morning there was a trough and a front that pushed through California, rain working it through central part of the state, and snowing currently up at the Tahoe region, maybe 5 or 6 inches expected at better locations. But anyway, a little bit of a trough here, pinched off, a little bit too tight, a little bit of low pressure, and that's about it. So really nothing obvious to support storm, gale, or swell formation. We'll roll this out, and as you go, you continue to see this ridge here, high pressure, just getting closer to California. That should generate just more north winds down the coast, just tearing things to shreds, and then a bit of a split becoming more obvious right in this region come about Tuesday night. We'll just roll this out, and that continues. Notice the split point here now back to about 160 east, but overall the jet is starting to get more energy in it by Thursday. Nothing, you really get excited about, but then you start looking here come Friday, and a consolidated jet is supposed to start materializing, pushing off of Japan, and of course all this split mess here, that's going to take a while to work its way across, assuming this guy has enough energy to make its way across the Pacific. Anyway, we go into Friday and Saturday, we're sort of tracking the split point here, and it makes it approaching the date line, probably here about 170 east. Still good winds holding, and a bit of a trough. Here you go, right here, that little sort of comma, starting to dig out on Friday night off the Kuril Islands into Saturday, and then even into Sunday, and the split point now just about reaching the date line. This is looking much better. The focus then would become the West Pacific for storm activity and therefore swell production. Again, this trough continuing to build into late Sunday night, as split point still looks like it's hanging about 170 east. So the overall picture is kind of a garbled mess, but come later in the week, more cohesiveness in the jet in the West Pacific, and better opportunity, or at least some opportunity, for gale production in the West Pacific. I'm sure the folks in Hawaii are dying to see this. Next, let's take a look down at the surface. As expected, high pressure, 1032 millibars, sitting here right underneath this ridge that's ripping through the Gulf of Alaska. Low pressure, you can see it here, working its way inland. Gradient, that is a difference in pressure between the high pressure here, low pressure here, creating winds, 25 knots. Maybe stronger along the coast. There was definitely some 30-knot gusts at select stations along Central California today. And then low pressure, another little low, trying to get organized here. We're sort of just grasping at straws, looking for any sort of fetch. And then, of course, this other low pressure system here. Notice high pressure here. This low is probably going to get pushed up above the high. And another high here. Anyway, difference in pressure. Again, another small gradient creating north winds at almost 40 knots here, but aimed to the south. Hawaii's over here, not a lot of energy aimed at them right now. Let's put this into motion. Roll this out. Notice we get more wind energy pushing to the south, getting closer in the swell window to Hawaii. And let's go back here. This little fetch here, Sunday night, was at 40 knot, almost west winds, 35 knots into Monday, and then moving into the British Columbia coast. Maybe good for some swell production there. And again, this fetch here now, working its way closer to the Hawaii swell window come about midday Monday. And roll this out. More fetch. I mean, nothing great, but at this point, any swell is a good thing. Also notice this high pressure here is generating very strong trades that have been the hallmark blowing into Hawaii for a week or two now, at least. A lot of east swell on the east shores of the islands there, but this is classic inactive phase of the MJO. High pressure takes over. You get enhanced trades, and the ocean the atmosphere doesn't do a whole lot for storm production because of the jet stream issues we talked about before. Anyway, we'll roll this out some more, and we get into Tuesday. This system is actually supposed to beef up a little bit again now, and then finally fade out. High pressure still the name of the game in the east, and then we start getting, come Wednesday, some low pressure developing off Kamchatka. 55-knot winds in a tiny little patch, and that just basically goes into the North Dateline region and dissipates. But another little low starts on Thursday towards the Dateline. Not doing a whole lot, and most of the fetch is more southwest fetch. And then we come into Saturday. This is new on the charts. This wasn't here, certainly not as strong as this. Even the last run, the 12Z run, this is the 18Z run, latest just posted. 45-knot winds, building 50-knot winds over a small area. We'll just roll this out and just sort of hanging there. That looks very good for producing some sort of a northwest swell for Hawaii and getting them in the game and back into sort of more of a winter type mode. Things have been pretty dead for a while, and certainly some of this swell will reach the U.S. West Coast kind of from a north angle. Great circle paths kind of go up and down, like, up this way, so not aimed well at Southern California, but interesting. Also notice this little tropical system projected, certainly not believable 180 hours out, but we'll take whatever we can get. We're basically groping for signs of the demise of the inactive phase of the MJO, and per the models, we're starting to see some of that. Let's get down to see how all these winds affect the ocean surface. So here we are, significant sea heights for the North Pacific Ocean, and here's our main area of swell production right now, this little low wandering towards the dateline, 26-foot seas, max seas at this position, aimed basically in no man's land. We'll roll this out, fish storm if you will. We continue, and so here's that little low we saw in the Gulf come Monday, gets 22-foot seas, and that's about it. And that's sideband swell into California, but winds are supposed to be blowing pretty good down the coast all week. Not a whole lot expected. High pressure here, core of the high, no wind, and of course, no sea production, but all the activities around the side. And here's the wind swell fetch from the trades or the high pressure blowing into Hawaii. But this is the main system to be watching, generating swell for Hawaii. Nothing great. I mean, here's more sort of sideband energy spreading. You get about a 30-degree spread without losing too much height into Hawaii. And it continues into Wednesday and then finally peters out. This will be good for some nice north-angled swell for the islands. Nothing huge, but rideable. And then here's our first little system. Again, tucked way up here, making to the northern dateline with barely 30-foot seas over a tiny area. Hawaii might see a little bit from it, and that would be about it. The second system we talked about before, 22-foot seas into Friday. Not doing a whole lot. Most of the energy is aimed at Alaska. And then we have our larger system here. Also notice the tropical system comes Saturday starting to develop, but the larger system, and we say larger, it's more stronger, not necessarily large. What was that, 34, 36-foot seas or so into Sunday, and then about 30-foot seas, but at least it's finally starting to cover a decent size area. It is the footprint of these systems. The larger area of fetch, the longer it persists and the stronger it is. You could have lots of really strong winds over a tiny little area, and they, more like a little hurricane. They don't do so much. You need a big footprint with maybe lesser winds that you'll get more swell and more period out of it in the long run. So a week out, things look encouraging. Let's do a quick review of the southern hemi. And we'll just sort of blast through this, guys, and we're sort of just watching this area down here, and basically nothing's going on of any real interest. We're into November. The southern hemi pretty much goes to sleep. The focus is all north, but just to be complete, whoop, that was it. So basically, nothing going on. Let's look at the long-term details. This is where the fun begins. El Nino 2015, and certainly a strong El Nino in development. Let's get into the details. So we'll do this just like weeks past. First, we'll talk about winds in the Kelvin wave generation area. That is in the West Pacific, mainly west of the dateline, just a few degrees either side of the equator, from about 170 to about 135. Right in here, you have west winds in here, and then you get, or at least have the ability to transport warm water in this area to the west in the form of a Kelvin wave. And what is a Kelvin wave? A Kelvin wave is a pocket of warmer than normal water that when west winds blow over warmer water, typically located in the far west Pacific, that pocket of warm water falls to depth down about 200 meters, traverses the entire length or width of the Pacific, erupts off the Galapagos Islands in Ecuador, forms like a warm oil slick of water at the ocean surface, which gets caught by trades and then starts migrating back to the west. And it is the other region we're interested in is this thing called the Nino 3.4 region. Again, about 5 degrees north or south of the equator. Draw a box right here from 170 to 120. And when you have warm water in there, that is at least warmer than normal. Half a degree above normal is the sign of El Nino. We are way, way past the half a degree above normal mark right now. But anyway, so let's start our tour. West Pacific, Kelvin wave generation area. Clearly, these are actual west winds blowing on the ocean surface. So we have some sensor outages somewhere out in here. Some of this data is suspect. This is kind of a modeled composite. So this is all generated by buoys that are strung in an array of buoys strung in lines across the equator. Of course, they're out in the middle of the ocean. They take all kinds of abuse, and sensitive electronic instruments don't survive well in the open ocean. So it's a constant maintenance nightmare for the folks that have to keep the buoys up. And so a bunch of the buoys are out, both at depth and at the surface. But anyway, rough picture, westerly anomalies, east trades in the east. These are actual winds. These are anomalies. Differences normal for this time of year. Clearly, we are finally starting to see the reemergence of reasonable, we'll call it modest westerly anomalies. So we had very strong westerly anomalies and west winds in the Kelvin wave generation area. Good westerly wind bursts basically the whole month of October, but come October 31st, boom, the bottom dropped out. The west winds just evaporated and it went dead calm. The atmosphere was likely in recharge mode. And now, just the past couple of days, we're starting to see better signs that things are starting to return to what we would consider a more normal pattern, given the absolute strength of El Nino that is in play right now. Let's go take a quick look at the model. Actually, before we do look at the models, let's take a quick look backwards starting November 9th. This is anomalies, again, 850 millibars. This is up about 4,500 feet. Still a good proxy for what's going on down at the surface. And again, Kelvin wave generation area, basically this box right here. So weak westerly anomalies, and we'll just scroll through this, even weaker here into November 12th and 13th. But the 13th, you start to see a little bit. Now, there's still westerlies going on over here, but that's not the Kelvin wave generation area. And if you get westerly anomalies here, you're not going to get Kelvin waves from it. We still want to see westerly anomalies because that's a hallmark of El Nino. Really, suppression of trades in this area is what we're interested in. But still, over here, the MJO, the active phase of the MJO, also promotes westerly anomalies in this area, and that helps feed the jet stream. So we're constantly looking over here, looking for west winds or anomalies, anything stronger than normal. So here's the high-res GFS model, Kelvin wave generation area, the main core of it, 3 degrees north and south of the equator. Here's New Guinea here. Date line is right here, and we're looking the whole way up to 5 north and 5 south. Anyway, we currently see a little pocket of westerly winds, just like what we saw in the previous charts here. What is this? So about 14, 15 nautical miles an hour. A little bit of easterly trades over here too. We'll just run this through, and what you're going to see is this pocket persist for a little bit, but then it fades out, and that's kind of it. And then we'll just roll this out. You can sort of watch it for yourself. Not a whole lot goes on. Basically, just a light wind pattern, north-south winds. That doesn't do anything one way or the other into Friday, Saturday. And then we do notice trades starting to build into the 13-knot range on Saturday night, and that actually builds an aerial coverage into Sunday, but then it too is kind of transitory. It looks like dead air off here to the other side. We have another chart that goes the next couple of 10 degrees over this way. We're not even going to look at it, but because this basically represents what's going on. Kind of a variable light wind pattern, neither strong westerly winds nor strong easterly winds, basically normal for this time of year. So here's another way to look at this. We've seen this chart before. We're going back in time, October into November. Blues are easterly anomalies. Reds are westerly anomalies, and when it gets into the whites and the reds, that's actual westerly winds. The date line is running down right along here, and so the Kelvin wave generation area is roughly here over to here. This is the whole planet on one page. So here we are. Here was the last of the westerly wind bursts, the end of October. Notice easterly winds trying to work their way in, like the inactive phase of the MJO. And by about October 31st or November 1st, that actually started. Our westerly winds really died off, and our westerly anomalies died off. And then here we started with, just like we saw in the last chart, the little pocket of westerly winds. That's been hanging on for a while now. Easterly winds still trying to get going here, but basically over at 120, 130 east, outside of the Kelvin wave generation area. And here's the forecast for the next week. Not a lot of westerly winds, and for the most part, whatever they are, they're supposed to be east of the Kelvin wave generation area. So basically, the forecast per the CFS model is a continuation of a neutral kind of wind pattern. So here's another variant on that chart, only this time we're going from the past towards the future here. And again, Kelvin wave generation area running somewhere like along here up to around here. In the past, you can see westerly wind bursts. Good strong one. This was westerly wind burst number 4. The reds are actual westerly winds on the ocean surface in the October time frame, and the second little pulse. And then here has been, per the CFS model, this dead space we've been in from November 1, basically nothing going on, and we can actually overlay the MJO pattern. You can see strong westerly winds associated with the active phase of the MJO. Then we're kind of in this inactive phase here, right in the core of it right now, and not a whole lot has been going on. But then there's this equatorial Rossby wave that's trying to have some effect here, and the thought is maybe in the next week or so we're going to get a little uptick in westerly winds. The GFS model, the one we saw before, doesn't show this, but CFS is showing it, and it's been doing a reasonably good job. What we're really trying to do is get ourselves into about the early December timeframe when the active phase of the MJO again takes over. Westerly winds start occurring. Now, this is, again, not so much in terms of Kelvin wave generation, because that's pretty much over, and we'll talk into timing on that, but that we're not so much interested in warm water transport to the east, because that we've got piles of that going on, enough to supply us all winter already. This is really just about feeding the jet stream now and generating surf and storms and that sort of activity. And then past January, everything's supposed to collapse. The model's been up and down about what goes on this far. We don't even care. We're just sort of looking this far out. So generally, the pattern looks like we're going to have to suffer a little bit longer, maybe through the end of November. The thought is the inactive phase of the MJO will completely dissipate by then, and then we'll be back in a much better place for storm production. And then, of course, the final overlay, the El Nino base state. This suggested that it peaked out on October 31st, that one little contour there. But still, basically, the core of it is, in terms of westerly winds and that sort of thing, was from September into the end of January. That's classic El Nino. Nothing unusual here, other than the fact that, yeah, it's a very strong El Nino, like historically strong is sort of the thought. So good data here to burn into your memory. Next we go subsurface. So we've talked about, here's the West Pacific, here's the East Pacific. This is the ocean surface. This is down 200 meters down the ocean into the ocean. Here are the anchor lines, the TAO buoys that we talked about. These little X's are sensors on the anchor lines. The point being, look at here. And there should be a line down here, I'm sorry, at 155, another one here, and there might even be more, but notice there's just this giant gap of lack of data. And so what you end up with is this basically a pretty poor representation of what's going on subsurface-wise. It's almost not usable, but you can sort of get a sense of where warm water is. The 28-degree isotherm, it's somewhere in the 120 to 125 range. That's about what you would expect. And 30-degree anomalies, I don't know whether this is real. I mean, 30-degree temperatures, I don't know whether this is real or not, because there's nothing here to confirm what's going on. Likewise, these are the anomalies. Actually, a couple of these sensors, it appears, maybe are starting to have come online somehow. They've figured a way to get it going, and this is the best-looking subsurface picture we've seen in 2 weeks now since these lines out here went inactive. Anyway, you get the picture here. This is much warmer than normal water in this area. This is the warm reservoir. Actually, so you have west anomalies here. They push warm water to depth. This is, I wouldn't want to call it a Kelvin wave because it's a lot bigger than a Kelvin wave and a lot warmer. It's suggesting 8-degree above normal temperatures here, and there are some active sensors in the area, so we'll go with that. Certainly seems believable. This is really the Kelvin wave from residuals from Kelvin wave number 3 and Kelvin wave number 4, all building this giant warm reservoir that goes from, what's that, 150. So basically south of Hawaii, the whole way into the Galapagos. Very impressive indeed. Here is a better image from a different source, higher resolution, that shows you what's going on, how they're getting the data. I'll be honest with you, we're not sure how we're getting it. If you're not getting it from sensors strung down anchor lines, I doubt that there are other floating buoys in the area with anchors. The Argos series of buoys, they're not fixed. They are roamers. They're all over the ocean. Perhaps that's where this data is coming from. Anyway, westerly anomalies, take warm water, push it to depth. Clearly we're seeing that is still occurring. Very warm water. It peaks out at 6 degrees here. We see a giant core of that. There is no sign of any upwelling or anything. I mean, upwelling cold water anywhere in the East Pacific. Also to note here, these little fingers coming up at about 103, and what is that, about 120, 118. And then certainly here, this is 3-degree anomalies from basically south of Hawaii the whole way over to almost, not quite, the Galapagos. And all this warmth is working its way towards the surface. So another way to determine how much warm water is at depth, this is from the Jason 2 satellite, sea surface height differences from normal. Strip out all the waves, the chop, the tides, all that sort of stuff. And basically what you end up with is a profile where you have below normal heights for this time of year. That suggests colder than normal water at depth. Above normal heights suggest warmer than normal water at depth. That is, warm water at depth expands, pushes the surface, makes a little bulge on the surface. And by little bulge, we're talking about a huge bulge here. This is 20 centimeter anomalies above normal, which doesn't sound like much, but the satellite's is accurate to, I think it's 2 centimeters, either 1.5 or 2 centimeters, extending from 140 out to about 110. That's 30 degrees. That's 1,800 nautical miles of very warm water. And we're not even looking at the 15 degree, et cetera, et cetera. The point being, piles of warm water at depth in this region, just confirming what we looked at, the chart we saw before. And I still really enjoy this chart. Upper ocean heat anomalies, same sort of thing, but it's got time involved now. So we're going back to December of last year. Small Kelvin wave, warmer anomalies going from west to east as we go down time. Upwelling phase of the Kelvin wave cycle, early part of this year, off the Galapagos. And then here we go. We get into what is the meat of what has been going on. 1 Kelvin wave in the springtime, a second one in the early summer, a very strong wave due to very strong westerly anomalies in the late June, July timeframe. This is Kelvin wave number 3. This is what's erupting right now. Actually, we suspect some of Kelvin wave number 4 is already erupting as well. And this is from very strong westerly anomalies that occurred in the October time frame we just talked about. Again, burn this in your memory. You're not going to see this large an area of anomalies that often. And again, we talked about this last week, the width of the anomalies at any instant in time going. So this one we thought was very impressive. It goes 10, 25, and you sort of can do some samples along your 10, 25, and really you couldn't get anything more than 25, or we'll be generous, say 30 degrees of coverage in this 2.5 degree anomaly area. But now this Kelvin wave here, we're going from 150 to 110. That's 40 degrees. That's 2,400 nautical miles of at depth warm water, 2.5 degrees averaged out, and that still continues today from 145 to 115. Again, that is to 105. That is 40 degrees width of coverage. Very impressive indeed. But also notice here, boom, this sort of digging in, and when you get this is you draw a line right through here. This is the upwelling phase of the Kelvin wave cycle, typically driven by the inactive phase of the MJO. That's what's happening right now, not affecting anything in the east, but at some point we expect there to be an upwelling phase of the Kelvin wave cycle, probably 2.5 months out. So where does that gets us into probably the end of January or so, and by that time we don't even care. So we've talked about westerly winds in the Kelvin wave generation area. We've talked about Kelvin waves migrating under the equator to the coast of Ecuador and the Galapagos. Now we start talking about the effects of those Kelvin waves as they erupt in this area, create a pool of warm water at the surface, and then get caught by trades and start pushing their way off to the west again. This is the hallmark signal of El Nino. This is current imagery, clearly a very warm. These are anomalies, differences in normal for this time of year. Actually, this time of year, trades are at their peak. The water is the coldest in absolute temperatures off of the Galapagos, but they are much warmer than normal because of El Nino, because of repeated westerly wind bursts and Kelvin wave eruptions in the area. Let's go back a month just real quick, and you can see this was the area that they called the blob. Some people had gotten all worked up over this warm temperatures here, but you can see now that that is already dissipating. Not too much of a concern. Those still temperatures are much warmer than normal. Also notice here, there was a lot more warm water in this area compared to what there is today. And also notice now the temperatures here were warm, but not incredibly warm. But now a month later, very warm out in this area. Kelvin wave number 3 has done its thing, pushing off to the west, doing much warming. So you look at this, go, very impressive. But let's compare it to 97 just to give a dose of sanity to the picture. And the picture's a little different, but you can clearly see the picture during 97 was much, much warmer in this area. But notice out here at 160 west, not so much. We go to 160 west here, much warmer out here. So it's just the difference in the character of El Niños. This one was an eastward, very much a classic El Niño crammed right up against the South American coast. Our El Niño seems to be a bit more west displaced. The focus of warming is out here, not so much near the Galapagos. We're, a little bit, you could use absolutes and say, well, all that matters is what's going on in Nino 3.4, which is this area from 170 to 120 here, draw a box there. Say that's the only thing that makes a difference, but that's not true at all, too. It is the total coverage of warm water over the entire area that has an impact on the jet stream. So clearly not as robust a signal as 97 in terms of our El Nino, but still compared to any other year other than maybe 82, 83, this is the strongest one in terms of what we've been able to see in the satellite era. Now that was 50-kilometer data. Here's the high-res data, 5-kilometer, 10 times more resolution. The point being, look at this. There's 1, 2, 3, just a continuous string of these are 4 degrees with embedded 5-degree anomalies, basically running from 100 out to about 150. Very, very warm water, and this is still developing. This just started come about right before Halloween, and his, we were going, wow, that's kind of impressive, and it's just gotten more and more and more expansive in its coverage. Very impressive indeed. So we'll go through each area individually, starting Nino 1.2 right close to the Galapagos and the Ecuador coast. Not a whole lot of, warming here, definitely. Any other year you go, very impressive. But compared to Super El Nino, you would expect to see a lot more warming in this area. We're not seeing it. This is when we say this El Nino is westward displaced. This is why we're saying it. And then we'll just go back about a week and look at what's happened over the past week. And basically nothing. It's all holding steady, not getting warmer, not getting cooler, just sort of holding its position and oscillating around. Then we move to the west some, and this is a most impressive picture. Here is that string of 4-degree anomalies that we see starting at 100, and they're not continuous, but they're so close they might effectively be. And if you're only measuring from 5 north to 5 south, and in this block, it starts actually, Nino 3.4 starts right here. It's nothing but warm water. Very impressive. Here's where we were a week ago, and here's where we are now. And we were very impressed by this, and now this is just like off the charts. This is great. This is exactly what you want to see. And then the final sequence out towards the date line. Here's the date line, this final little pocket here. We notice we see 4+ degree anomalies showing up here. Otherwise, this is about as big and as far to the west as it's been all year. The best image of this sector, along with the best image from the one we just looked at. And then we go back a week ago, and yeah, maybe it was going out a little bit further, but it's more concentrated back here, so it kind of a wash. 6 of one, half dozen of another. I'll take either one of them. Great to see this. So putting that into perspective, it is this area here that we've been looking at. This is the trend, the past 7-day trend, and what this is showing is a little bit warmer here in Nino 1.2 off Ecuador between the Galapagos, and a couple little pockets here, but basically, and a little bit of warming out here towards the date line, but basically everything's steady state. We're certainly not losing any temperatures anywhere, steady state or warming across the entire region. Don't know how much more warmer it can get, but it might still continue to surprise us. But the point being, surprises are good things when they're in the right direction. When the ocean does things that you didn't expect in your wildest imagination in a good way, and in this case from the development of El Nino, that's a good sign. And we've been sort of waiting for that to happen with this El Nino. It just hasn't done it. Yeah, we get westerly anomalies. We think we're going to get a big Kelvin wave and stuff. It just hasn't been inspirational until now. Now it's looking pretty solid. And yet one more view of the same area, and here you can actually see the embedded 5-degree pockets in this stretch and the coverage of 4-degree anomalies, both here south of Mexico and then off south of California. Very impressive indeed. Just great imagery. The thing is, so we have this super high-res image now. It didn't exist in 97, and there was not even a hint of anything like this back in 82. So it's kind of hard to compare apples to apples. But if you want to do a comparison, and this is the only data that we have that we can find to do it accurately, and it's the same platform the whole way through. October 82, here was the 82 El Nino. Here was the 97 El Nino. Massive in comparison. Look at that. And then here's our current El Nino, which, notice, is a little bit westward displaced, but still very solid and stronger than the 82 at this time of year. So we're in one of the top 3 is what it looks like from this imagery. And then just one more, because 82 was a later blooming El Nino, so here it was about at its peak, December of 82. The January image is very similar. Here is the 97, which is effectively at its peak. Actually, it might have been November, but close. You're getting the general idea. And then here's where ours is right now. So we'll just sort of run back and forth through all these. And you get a sense of where we're at. We believe there is much more development in ours to come. Not so much in this area, but in this area. So ours is thinner, not quite as just expansive as 97. But looking reasonably similar. Again, probably not as broad either as 82 either, 82, 83. So it's hard to say where this is all going to play out at, but we're in very close company with the 2 strongest El Ninos, super El Ninos on record. And whether we make it to super status or not, hard to say, but we're in good company in that realm. And then actual water temperatures, this is not, anomalies from normal in the Nino 1.2 region. Again, we're kind of just meandering in the 2-degree realm, not very impressive. If we were up in the 2.5-degree realm, we'd be more impressed. But all the satellite data we've shown says this El Nino is a bit westward displaced away from the Galapagos. No big deal there, but the real eye-opener is this image. Here we go. The CDS Nino 3.4 index now basically off the chart, peaking out at 2.992 degrees. That's as of 18Z November 15th. Very high temperatures. And it doesn't look like it's going south anytime soon. And you can see the trend. The trend has just been steady upward. This is consistent with all the other data that we've been seeing from all the other images. So very high temperatures indeed. El Nino kicking into gear, and Kelvin wave number 4. It probably is feeding some of this, but the bulk of it is not yet erupted yet and not expected. Well, let's put it this way. If it peaked out in the, let's say, October 15th, it wouldn't be till Christmas time. If it was a normal eruption cycle, about 2.5 months later till it actually started hitting the surface. We think some of it is hitting now, though, but certainly will continue into the December time frame easily. We should see very high numbers out of the November monthly indexes, especially we're looking at the ERSS2V4 data. We want to see some high numbers. That's the most conservative one, but that's what we're using to compare to previous El Ninos to see whether we're going to get a sense of whether we're going to reach super El Nino status or just remain as a very strong El Nino. Next up, Southern Oscillation Index. We're going to start talking about coupling to the atmosphere. So we've talked about westerly wind bursts, we've talked about Kelvin waves, we've talked about Kelvin waves erupting in the Galapagos, we've talked about the warm surface pool in the Nino 3.4 and 1.2 regions. Now, none of it means anything unless it's having some effect on the atmosphere. This is the difference in pressure between Darwin, Australia, and Tahiti. You want to see negative numbers here. We're not seeing that. We were down in the minus, we had some individual readings at minus 40, but we were consistently down at minus 20, minus 25. We're basically at dead neutral now. This is all the result, and here you can kind of go and see how things have been playing out. Once we got towards the end of October, the inactive phase of the MJO took over. It's not unusual to see these numbers bouncing around like this. The 30-day running average, it was down in the minus 22 range, minus 2261. Now we're up to minus 9. We want to see this down in the minus 20 range. And then the same deal, the 90-day running average, you want to see it at minus 18. We were there. We were even down in the minus 19s. Now we're down to minus 15.9 and heading up. The longer the inactive phase of the MJO is in control, the higher these numbers will go. And here is a graph of the 30-day running average, Southern Oscillation average. In 2013, we were in the basically we're in La Nina. Then we got into January, tried to go to El Nino, and then here we are now. It's just been a steady downward trend, but notice there's been upward spikes. The MJO has still had some influence. We're in a pretty good run right now. We still expect this to fall negative, and there's been some historical data that suggests in the October time frame in Super El Niños, the SOI moves a little bit. You know, you get a bit of an inactive phase that comes in before you jump into the meat of winter. Don't know how relevant that is or not, but we're not exactly freaking out by any of this now. There's way too much warm water in play to deny the atmosphere what's going to come to it. There's just been a wholesale global shift in the ocean temperature balance and in the winds that are driving all that. So the expectation still is this winter should be a very stormy winter indeed. And then there's the ESPI, which is sort of like the Southern Oscillation Index difference. The Southern Oscillation Index difference in pressure between Darwin, Australia, and Tahiti. The ESPI measures difference in cloudiness between this region and this region. Same sort of deal. What you'd expect if there's warm water here, you'd have a lot more clouds above it, and then it would become a lot drier over here. The current number is 0.92, down considerably. It was up in the plus 2.4 range. Now, the interesting part about it, and we'll just use this graph, but there's other graphs. The short of it is, if you compare the temperature, the ESPI, the black line, to actual temperatures in the Nino 3.4 region, what you find is the ESPI leads by about 2 to 2.5 months, and then temperatures follow. When the ESPI this year was at its strongest back about 2 months ago, sea surface temperatures were warm, but nothing impressive. Now they're catching up and just going off the charts, so that theory seems to be holding true. And so what's the thoughts on this MJO thing? We need to get out of the inactive phase. Well, this model, the statistic model, suggests that it is supposed, so the oranges and yellows are the inactive phase, more reflectivity off the ocean surface due to lack of clouds. We saw that in the ESPI index. And the active phase, the MJO, is currently holed up south of India. And per the statistic model, it's supposed to be, the active phase is supposed to be working its way into the West Pacific. We don't necessarily believe that over the next 15 days. The dynamic model suggests basically a steady state of where we're at now. We're not sure we believe that either. And the phase diagrams from the ECMF model and the Ensemble GFS model, again, this is tracks the active phase of the MJO. Currently, it's crashing over the Indian Ocean, just like what we saw in the previous charts. And the thought is, as the active phase of the MJO crashes over the Indian Ocean, we suspect the inactive phase over the West Pacific is going to lighten up too, and that will give the El Nino base state a chance to sort of return to dominance and start getting us in what we would normally consider a pretty active weather scenario as we start working our way into winter. So to wrap this up real quick, right now, not a whole lot going on storm-wise, high pressure kind of in control, but a week out, the models are suggesting a more active pattern in the West Pacific. That's exactly what we want to see. That would give us a hint that maybe the inactive phase of the MJO is fading out. Jet stream's supposed to be getting more organized. On the El Nino front, El Nino is doing very well. Very warm temperatures in play, record high temperatures for that matter. Focus more in the Nino 3.4 region, not so warm in the Nino 1.2 region, so that doesn't put us in contention for a 97 sort of event, though we might still be a contender for an 82-83 type event, somewhere in there. Either way, it's way better than where we've been for the past 4 years, and we are getting already some snow up in the Sierra and some rain, so things are looking marginally better. We just really want to see the jet stream pull together and start really ripping across the North Pacific. We haven't seen that yet, but we believe that is coming probably 2 weeks or 3 weeks out at the latest. So for now, good things in play. We're just kind of in wait-and-see mode. Anyway, that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.